What's up guys, we're going to be taking a look at this lab, broken brute force protection, multiple credentials per request. The idea is that some web apps may have an element of brute force protection in place that prevents us from trying a long password list. At some point, we're going to be time throttled or locked out. However, just because a web app has brute force protection in place doesn't mean there aren't ways we still may be able to brute force a login for that web app. And this is an example of that, multiple credentials per request. The idea is we're not going to be making multiple requests here. We're going to be making a single request, but that single request is going to contain multiple credentials. So it's a type of brute force attack, even though it only makes use of a single HTTP request. All right, let's take a look at the lab. We're going to assume that this web app is otherwise protected against brute force attacks. So there's no point trying to directly brute force this login box. Let's start by logging in as a valid user and taking a look at the subsequent HTTP post request that's generated by that login. So here we are in the burp repeater. We can see a copy of the post request to the /login endpoint. And we can see that as part of the post body, we have a JSON object. Username, Wiener, password, Peter. So we can see a single username and a single password representing our login attempt. Now, since JSON is being used, there's potentially some type of JSON parsing that's taking place on the back end of the web app. One of the things that we can do with JSON is we can actually include arrays for specific values. So for example, instead of just having a string for the value of password, we could actually make use of an array. And inside that array, we have a list of strings. This is valid JSON. Now, obviously, what should happen on the back end is that when the server receives an array as part of the password value, it should say, well, I'm not looking for an array. It should discard the request. It should return an error, etc. But assuming the backend is not coded correctly, what may happen is it actually just starts working through the array, looking at the different values in the array and trying them as potential password values. This is obviously not what's supposed to happen, but this is what can sometimes happen if the web app hasn't been coded correctly. And this type of attack, it isn't exclusive to JSON objects. It could also be used as part of the post request body, as part of a regular post request. In other words, when we have key value pairs, username equals, we could actually just delimit this with an and. So we can say something like username equals Carlos and password equals password. And then we could use another ampersand and specify a second username and username equals Wiener. So you can see it's possible even with a regular post request body to potentially submit multiple credentials as part of a single request. Again, this should be handled correctly on the back end where it potentially just discards a request or only looks at the first value. It shouldn't loop through everything, because if it loops through everything, then we actually have a type of brute force attack. So the next step here is to actually populate that JSON array with a list of potential passwords. We can use the Portswigger password list that they provide for use with their authentication labs for this. Now, here is the raw password list taken from the Portswigger site. We have formatting issues here because what we really need, each of these passwords should be inside double quotes and they should have a comma between each password with no comma after the last password. Now we can use a tool such as Notepad++ to format this. In fact, if we press Ctrl and H, we find ourselves in the Replace tool. We can make use of regular expressions. For example, if I make use of an anchor sign, this means that we are going to insert the desired character before the beginning of each line. In a regular expression, the anchor represents the beginning of a line. So if I replace the anchor tag with a double quote and choose Replace All, we can now see every line in the document is prefixed with a double quote. Another very useful regular expression character is the $sign. This represents the end of the line. So if I replace the end of the line with a double quote and a comma, I'll choose Replace All. We can now see we have a list of passwords inside double quotes delimited by commas. Now this is mostly complete, but it's good practice just to remove the last comma from the list. Depending on the language, this doesn't always break arrays. There are some languages that are okay if the last value in the array has a comma after it, but just to ensure compatibility with everything, it's a good idea to always remove the comma after the last item in the array. Now we actually have a list that we can simply copy and paste in between the square brackets. We've already added the square brackets to the JSON object here, so it's just a case of pasting our list of passwords. So you can see we have an array, all of the passwords, we have the end of the array, then we have the end of the object. Now let's submit that, see what we get. One thing that we need to do as well is change the username to Weenie. We actually get a 200 response, and that's likely because we're already authenticated with that particular account. So we'll change the username to Carlos, which is the victim here. This time you can see we get a 302 found response. That implies that we are being directed to my account, which implies a successful login. If we right click on this and choose request in browser, copy the link to the clipboard, let's paste that URL, and you can see we are now authenticated as Carlos. So the implication here is that one of these passwords inside the JSON array was a valid password. We don't know which one was the valid password, but it doesn't really matter. We're now authenticated as Carlos. The other implication here is something is not quite right with the way that this is being handled by the backend. Obviously, the backend is not expecting to receive an array as the value for the password field here. So it's not always clear how it's going to respond. But in this case, it's obviously trying the passwords inside the array to see if they authenticate the user. And presumably after reaching a valid password, that's when the 302 is issued. It may be that the backend doesn't even bother trying to validate against the rest of the passwords. We don't know exactly what's happening on the backend. It's a little bit of a black box. However, we do know that something's not right in the way that it's handling this array. We probably should just get some error back from the web app. So this, in summary, is a slightly different type of brute force attack. It is a brute force attack. It's a different flavor because there's only a single request that's taking place here, and all of the attempts at guessing the password are inside that single request. So this way we don't trigger any lockouts or time throttling as a result of submitting a large number of requests. This is not a very common vulnerability. It's more likely that you're going to be able to brute force a web app the regular way if it doesn't have protection against brute force attacks. But this type of attack does still exist in the wild. It might be something that you want to try just to see how the web app deals with multiple credentials in a single request. And in this case, web app didn't handle them correctly and evidently tried to authenticate against all of the credentials that were submitted as part of a single request, generating a brute force attack vector. All right, hope it was helpful. Thanks for checking out the content, and I'll catch you guys in the next lab.